All right, here we go. So, let's start with the basics. X squared plus 6x plus 8. How do we factor that? Two sets of parentheses. Split up the first terms. List the factors of the last term, 1 and 8, 2 and 4. Which factors have a sum of the middle term and multiply to be the last term? Plus 2 plus 4. Factory. Okay, that's the basics of factory. Now, what if we have like 2x squared minus 5x minus 3? Okay, 2x squared minus 5x minus 3. Ooh, there's a middle term there, isn't there? Okay, should we do the wheel dryer method? AC method? If there's a first term in front, okay, and you can't factor it out, you can't factor something out, and it's not a perfect square, as if the first and last terms aren't perfect squares, then it's the AC method. 2 times 3 is 6. What are the factors of 6? 1, 6, or 2 and 3. Now, we need factors of 6 that add up to a negative 5, but they have to have opposite signs. See how we have a negative 3 there? We have opposite signs. Which have opposite signs that add up to a negative 5? 1 and negative 6. So then we rewrite this. See how it's 2x squared? We're going to write this as 2x plus 1 and then 2x minus 6. Okay? This is a wheels method there. So now, what's the greatest common factor of these two? 1. What's the greatest common factor of these two? 2. Divide by the greatest common factor. So this is 2x plus 1. This is x minus 3. If you would FOIL this, what are you going to get? Well, it's 2x squared. Outers is minus 6x. Inners is plus 1x, which is negative 5x minus 3. Easy peasy lemon squeezy, right? Okay? So how do we apply that? How do we apply that to trig? Well, the only difference between this and trig is in trig, we'd write it as 2 cosine squared of x minus 5 cosine of x minus 3, which 2 times 3 is negative 6. Factors are 1 and negative 6. So it's 2 cosine of x plus 1 cosine of x, 2 cosine of x minus 6, divide by 2, divide by 1, and it'd be 2 cosine of x plus 1 cosine of x minus 3. It is no different from what I did right there to what I did right there. The only thing is, instead of having an x, I have a cosine of x. Okay? Is it any big deal? No. Okay? So let's do another one. Let's do 4 tangent squared of x minus 13 tangent of x plus 9. Ooh, this isn't a very nice problem. Okay. Normally I would say, well, you do this by a perfect square trinomial. Take the square root of that, but the middle has to add up to their sum, which it won't. So, how do we do this? Well, what's 4 times 9? 36. What are factors of 36 that add up to negative 13? Negative 4 and negative 9, right? So, you go 4 tangent of x minus 4 and 4 tangent of x minus 9. Divide this one by 4. Divide this one by 1. So it's tangent of x minus 1 times 4 tangent of x minus 9. So if we'd FOIL this, tangent times 4 tangent is 4 tangent squared. Outers is minus 9 tangent of x. Inners is minus 4 tangent of x, which adds up to negative 13 tangent of x plus 9. Okay? All right. So what other factoring methods are we going to do today? Well, we're going to do perfect square trinomial factoring. And you're going, what's that? Well, that's when we have like 9 cosine squared of x plus 24 cosine of x plus 16. Okay? When the first and last terms have square roots, it's a quantity squared. What's the square root of the first term? 3 cosine of x. What's the sign of the middle term? Plus. What's the square root of the last term? 4. What's 2 times 3 times 4? What's 2 times 3 times 4? 24. This is the answer. That's how you check to make sure it works. If you take 2 times the first term times the last term, it has to equal this for a perfect square trinomial. Okay? Are you all right with that, Chanty? You're great with that? Okay, perfect square. Should we do one more perfect square trinomial? Kind of sounds like we should. Let's go 25 secant squared of x minus 20 secant of x plus 4. Yeah, that'll work. So, first and last terms each have square roots, right? So it's quantity squared. What's the square root of the first term? 5 secant of x. Sign of the middle term? Minus. Square root of the last term? 2. Is 2 times 5 times 2, 20? Yep, it works. Okay, that's perfect square trinomials. Now let's look at difference of squares. Sine squared of x minus cosine squared of x. Okay, a difference of squares is like x squared minus 9, which is x plus 3, x minus 3, right? Okay, so this would be sine of x plus cosine of x, and sine of x minus cosine of x, called difference of squares. They're conjugates of each other. Okay, so that's difference of squares. Ooh, let's do another difference of squares. Let's do tangent to the fourth of x minus cotangent to the fourth of x. How do you do difference of squares here? Same thing but squared. So tangent squared of x plus cotangent squared of x, tangent squared of x minus cotangent squared of x. Bada bing, bada boom, we're done, right? No, we're not done. Why aren't we done yet? Second one is still difference of squares. We got to keep going. So tangent squared of x plus cotangent squared of x. Sum of squares doesn't factor, but difference of squares does. So tangent of x plus cotangent of x, tangent of x minus cotangent of x. Okay? So we can keep going with that. All right. Then, what if we have something like this? What if we have cosine cubed of x sine of x minus 4 cosine squared of x sine of x minus 5 cosine of x sine of x. Ooh, this doesn't look like it's any fun. What do you see that's been different about this one compared to all the rest? Mr. Hawks brings up a good point. He goes 3, 2, 1. So we're not used to 3, 2, 1. We were used to 2, 1, 0. So if it's 3, 2, 1, we need to take out. So we're going to take out a cosine of x. Well, if we can take out a cosine x, what else can we take out? We can take out a sine of x because it's in all of them. Hey, that's like greatest common factors. Now I'm left with cosine squared of x minus 4 cosine of x minus 5. All right. So this stays on the outside, and then I factor what's left. Cosine of x plus minus. We're factors of -5 that add up to -4. 1 and -5. Okay, taking out the greatest common factor. Okay, our last thing that we're going to hit is what if there's 4 terms? So if we have secant of x cosecant of x plus cosecant of x plus secant of x plus 1. If there's 4 terms, we factor by grouping. What's the greatest common factor of the first two? Cosecant of x. And we get secant of x plus 1. What's the greatest common factor of the last two? 1. 1's the only thing that come out of there. Secant of x plus 1. So it's cosecant of x plus 1 times secant of x plus 1. Okay, I went through a lot today. I went through a lot of examples. So I'm going to throw this into a video, throw it on Classroom. So if you need to speed through the video to look at an example, you can certainly do that. Your assignment is on page 172, numbers 23 through 36, all of them. All right. Remember, you have study all Monday morning where you can always work on this if you're not in both band and choir.